So over here we've got a coordinate plane where each intersection of the circle on the coordinate is 1 unit away from the origin. That is why it's called a unit circle, and by knowing that, we could plot all the interceptions. The first one is at 1, 0, and then we could go to 0, 1, and then we've got -1, 0, and last but not least, 0, -1. So now let's move on to labeling our quadrants. First, we've got quadrant 1, and then to the left is quadrant 2. Below is quadrant 3, and to the right is quadrant 4. So now if we draw a radius on the circle and drop it down and draw a right triangle, we know that the hypotenuse of the triangle is going to equal 1, since that is also the radius of the circle, and because it is a unit circle, the radius is always 1. So now we could label the base of the right triangle as x and the leg as y, and we could look back at SOHCAHTOA, and by doing so we could figure out that sine of theta is going to be opposite over hypotenuse, which is just y over 1, which obviously equals y. And then cosine of theta is going to equal adjacent over hypotenuse, which is x over 1, equaling x. And tan of theta is going to equal opposite over adjacent, which will be y over x. It could also be written as sine of theta over cosine of theta, since we know sine equals y and cosine equals x. So now we could label this point as x, y, because we know that we're going x coordinates to the right and y coordinates up. And since we know that sine equals y and cosine equals x, we could substitute y with sine and x with cosine, and our coordinate can be labeled as cosine, sine. And then using what we know from any circle, we know that this point would give us 0 or 360 degrees around a circle, and then we could use what we just learned about converting degrees to radians to convert that 0 radians or 2 pi radians. We could do the same thing for each point, where this point would equal 90 degrees, so converting that would be pi over 2 radians. This point would equal 180 degrees, and you could see that because we're going halfway around the circle, which is 360 degrees, and converting that would equal pi radians. And then this last point over here is at 270 degrees, and converting that equals 3 pi over 2 radians.